Find the equation of a line passing through the point 3, 2, which cuts off the least amount of area from the first quadrant. So let us draw the picture. Say 3, 2, 3, 2 here. I draw a line. So a line could be this line, this line, this line, or maybe vertical line, horizontal line. But we want the least amount of area, cut off the least amount of the area from the first quadrant. So we want some lines like this. We do not want infinite area. Or maybe it can never cut off the first quadrant at all. So let me draw the line, say this line. I just draw a random one, but it should cut off one part of this, so this part. And this one is the area we want to minimize. The point is 3, 2, and the equation of a line that you should know is a line passing through equals L, passing through a point which has equation y minus y0, y minus 2 equal to the slope x minus x0. So this is a line. So this is our slope which we need to find. And we know that we don't want the slope 0. We don't want, say, y equal 2, for example. Y slope now let's see what is the 2 points here. This is the right triangle. We want the 2 points. We want to compute the area. Let's look at this point first. So this point has the y coordinate 0. So y equal to 0. Then you have 0 minus 2 equal to m times x minus 3 minus 2 equal to mx minus 3m. So m times x equal to minus 2 plus 3m. M different from 0, I can divide by m. 3m minus 2 over m. This is our x. The first point here has the coordinates 3m. I don't know if it's nicer to write if this like that, 2 over m. So 3 minus 2 over m, comma 0. This is the coordinate of this point. Now we do similarly for the coordinates of the other point, this point. So x equal to 0, y equal to what? Now x equal to 0, x equal to 0, y minus 2 equal to m times 0 minus 3 minus 3m, y minus 3m plus 2. So the point has a coordinates 0 minus 3m plus 2. This is the coordinates of the second point. Now you know what is x and y. This is one length, this is the other length. So 2 lengths we know here, we can compute the area. So let's compute the area of the right triangle. Let me denote by A equal to 3 minus 2 over m. This one we want positive. We want this one's positive too. Minus 3m plus 2 divided by 2. So condition for us is each of those lengths need to be positive. We need minus 3m plus 2 positive. We need 3 minus 2 over m positive. That is our restriction. So let's look at this. Now we see that's because of our line going down, decreasing like that. This means that the slope needs to be negative. Our slope m is negative. So let's look at the first condition here. 2 bigger than 3m. For the second condition here, you have 3m minus 2 over m positive. M is negative, so the numerators must be also negative. 3m minus 2 negative, 3m less than 2. So both equation you have 3m less than 2. So this system with this condition gives us the condition on m less than 2 over 3 and m less than 0. So it doesn't help us here, m less than 0. This one is better condition. So the restriction we use for m is m less than 0. This is our restriction on m. Now let us multiply on this. Area 1/2, 3 minus 3m minus 9 times m plus 6 minus plus 6 over m times m minus 4 over m. 1/2 minus 9 times m plus 6 minus 4 over m. So we have 1/2 12 9m 4 over m. This is our function area in terms of the variable m negative. Now we need to compute the critical points. A prime equal to 1 over 2 minus 9 minus or plus 4 over m squared. This one equal to 1 over 2 4 over m squared. I can write as 2 over m squared minus 3 squared. 9 here equal to 3 squared. So 1 over 2 over m minus 3, 2 over m plus 3. Now this is our A prime. A prime equal to 0 if and only if this one equals 0 or this one equal to 0. But we want m to be negative, so this one is always negative. So only this term equals 0, m negative, so 2 over m plus 3 equal to 0. 2 over m equal to minus 3, m equal to minus 2 over 3. this is our critical point. Now we will write down the table. M minus infinity to say 0. Critical point minus 2 over 3. A prime of M. A prime of M equal to 0 at the critical point. A of M. Now we need to determine the sign for A prime of M. A prime of M is given by this formula. So look at this. 1/2 positive, M negative. So this term negative, this term negative. So it really depends on this term. So let me just rewrite on here. Equal to this times M. Up there you have 2 plus 3M. Until here we keep the same. M is negative. We know the sign of that. I can take it out too. So we really have 2 plus 3M. So because I have 3 coefficients there, let's write out 3. Inside you have 2 over 3 plus M. So that's what I rewrote for these terms. So now look at that. M plus this really depend on this sign. Negative, negative. So this term positive. A prime positive when this one positive. A prime M. A prime M positive. If and only if this one positive. So really depend on the side of this. So as you see that it is positive when M bigger than negative 2 over 3. Negative when M smaller than that. So A decreasing here, increasing here. So area is minimum when M equal to negative 2 over 3. Area M is minimum when M is negative 2 over 3. So we need to find the equation of that. Equation of that is this one. Equation of the light is given by this formula. Y minus 2 equal to minus 2 over 3 x minus 3. Or you can rewrite as minus 2 over 3 x minus 3 plus 2, or any form you want, or this one plus something. So here's our final answers. This is the light which minimizes the area of the triangle, or it's cut off the least amount of the area from the first quadrant.